Okay, so we learned about in the previous video, we learned about the hypothesis test, the general steps that we had for the hypothesis. And we said that, okay, so for the conclusion step, we are going to compare the value that we have for the Z null with the Z alpha. If we were in the rejection area or region, we would say that we are going to reject the null hypothesis. And if we were not, we would say we failed to reject the null hypothesis. And then we had an example and worked on that. So that's the classic approach that we have. Another way that we can make our conclusion is that comparing this alpha with the amount of the something similar to the alpha that we will get from the Z null. So look at here. Let's assume that this is this is normally distributed. This is a normal distribution curve. So we said that previously we said, okay, so here is my alpha, right? So I would say here is half of the alpha, half of the alpha. I would say C here is the half of the alpha, half of the alpha. Then we find out that's the classic approach. We will find out the Z of the Z null from the test statistic. And for different categories, we had different test statistics. We're going to compare it, and we said that if we were in this region, whether you, for example, if you had your Z null here, we would say we are in the rejection criteria. If we had our Z null here, we would say we are not in the rejection region, so we fail to reject the null hypothesis. So what are we going to do here? It's like that. Let's think this way. Think that, okay, I have my half of the alpha, and I found that Z of the half of the alpha, and then Z null from the statistic, and compare that. What about if we were doing something else? We're saying that I have this half of the alpha. I know that here is this area, all of that is half of the alpha. What about if, when I find out my Z null from the test statistic, what about if I go back to the table and find out the phi that I would have for this Z null at this Z null? So what would the value of the, we don't name it alpha, but it's similar to this, the probability. So what would be the probability that I'm going to have for this Z null? So it's like this. If I have Z null here, right? Let's say this is my Z null. What would be this amount? I can read it from the table, right? I have to, table is the cumulative, so I would need to say 1 minus this amount from here to here, like here, right? I'm going to find out this one. So look at here. If we call it p-value, first of all. So this value is going to be p-value. If my p-value is less than this amount of the half of the alpha that I have here, then I can say that, okay, so I'm in the rejection region. So this is another approach. It's for the hypothesis test that we have learned. I'm going to write down here. So here is that how we calculate the p-value. We will see that if we have two-sided test or one-sided test. So the way that it works is that for the p-value, the only thing is that the p-value, if it's two-sided, so this Z null, I would need to see that what's going to be equivalent of this one here. So for the p-value, I would need to add this one, sum this one with this one to get the p-value of it. So I would say p-value it's equal to. If I have two-sided, my p-value is going to be, I said that we have to add these two together, right? So it's going to be 2 times, and for finding out this one, for the Z null, what are we going to do? We said that it's going to be the 1 minus this amount. So it's going to be 2 times 1 minus phi at z0. So that's going to be the value for my p, like the p-value that I want to have. And then if it was, what about if it was one-sided? For the one-sided, we can have the upper one, upper tail test, or the lower tail test. Let's say I have an upper tail test, and when I have upper tail test, it means that my alternative for the two-sided, the alternative hypothesis was mu is not equal to mu null, right? So if it's upper sided, I would say first of all is one-sided, and then H1 is that mu is greater than that mu null. So in that case, my p-value is like this. If I had like, if we didn't have anything here, it was just this, it would be upper sided. So it's going to be 1 minus phi at 0. If it was the lower tail, so meaning mu was less than mu null, in that case, my p-value would be this amount, right? So it would be, if it was one side, so it would be phi at z0. So these phis, when we want to find them, we would go back to the table and read it for the z0 from the test statistic, whatever it was. We would go back to the table and find out the area under the curve for this value. So in fact, look at here, we find out the area under the curve. If this one is my z0, right? So I'm going to find out the area under the curve up to this point. So for this one, because we're looking for this area under the curve, I would need to say that 1 minus whatever I read from the table, 1 minus this area. So this is about the p-value. Then with the p-value, we would compare it with the alpha, half of the alpha or alpha, and then we make our conclusion. So that's the another approach for the hypothesis test that we learned.